Hello and welcome to the sixth in our series of demonstration videos for the VPAT product. This will be a continuation of the capacity planning functions we discussed and demonstrated in our fifth video. We're going to pick up where we left off, and in this video, as we discussed, we're going to look at modify workloads, where we can change workload utilization to show forecasts of growth at the workload level. And we're also going to look at other controls other than annualized growth that we can apply at the KEC and LPAR level. So let's start with modify workloads. So if we click on modify workloads, VPAT is going to go through all of the LPARs in this LPAR report file. And remember, this came from our extract process. It contains information on the systems that are on this KEC. So when we click on modify workloads, VPAT's going to ask us, well, what LPAR do you want to modify? And the workload report files, remember, are service class data. So VPAT is essentially saying what LPAR and what service classes do we want to artificially change and simulate. So we're going to select our workload file here, and we're going to go into the select, and we're going to pick our workload file that we created. Now, if we had more than one LPAR report file here, we could cycle through them with this next button as we continued. And if we wanted to change workloads in more LPARs, we could simply check these and select those files if we had them. In this situation, we're going to go here, and now we're going to be presented with a roster of all the service classes that are in our system during the observation period. This is presented in descending priority order. So what we're going to do here is we're able to go in and we're able to modify what we want to change in terms of CPU utilization at the service class level. So in this example we're going to do right now, we are going to look at artificially increasing the CICS, the DB2 workload by 20%. So I click on each row in the table and I click on the percent change that I want, and VPAT will restore that and we'll apply that when we're done. If I want to eliminate a workload completely, I can put a -100 in. So if we were removing CICS from this LPAR, we might put a -100 in this field. In the meanwhile, I'm going to continue to go through each of the DB2 service classes and make a change to reflect a 20% growth. Now, when we do this, VPAT is going to, when we're done with this, VPAT is going to take our changes. It's going to look back through the service class data, and it's going to determine the delta in total CPU that we are telling it to simulate. So if we're increasing each of VPAT of the DDF service classes, DB2 service classes here, VPAT is going to go through and look for all the occurrences of these and add in an additional 20% to each of the CPU usage numbers. Now, what it's going to do with that is going to allow us to store this separately, and it's actually going to apply it back into a temporary LPAR report file. So we're going to click complete the changes here. And when we say update, we're telling VPAT we want to create an updated version of this LPAR report file. And this new version will add in and simulate the addition of the additional DB2 workload. So rather than calling it new, let's call it DB2-20 PCT. And we're going to say save. So that's successfully written. Now, again, if we were modifying more workloads and more LPARs, we would click next LPAR. Since there is nothing else selected, we click next LPAR. We come back to here. Again, if we had more LPAR report files, more KECs and more LPARs that we wanted to modify from different machines, we would click next LPAR report file, and it would cycle us to the next one. Since there is no next LPAR, we click that, and we're back to our main panel. So how do we use our data we just modified? Well, we're going to select here, and we can now see here's our data. Here's our modified LPAR report file that includes our 20% growth. Click OK. I deselect our original, and now I select our new version, and we can see now that we can go through our normal charting process just like we saw in our first video. We can click Start. We can modify this as needed for any changes in our system configuration during the observation period and overlay with ZPCR numbers there. We click Return here. We're going to talk about this next, but this is where we can also change LPAR and KEC level workload usage. We're going to click OK and leave those alone for now. And now we know if we click on MIPS, we can now see that if we look back, well, that 20% growth in DB2 has pushed us above our current capacity. So that could be a problem. That may not be a problem, but at least we are aware that this workload change has the potential to change what's going on a machine, and it's likely going to increase our period of time that we sit at 100% in the middle of the night. So we can accurately say back to our management now what the impact is going to be. And if we look again here, we can see our utilization number. We can look at now, we can see that the projection is we have a much longer period of time at 100%. And we can also see now that, well, if we do go to the 7-Eleven to accommodate that growth, that historically our workload, if it were to run unchanged, we would probably only hit about 95% utilization. So again, we may have latent demand. This might be just a simulation, but this should imply that we would have no degradation to our production performance or any performance should we have this DB2 workload growth in our Prod 3 LPAR. So that's an example of how we can use this function to demonstrate workload level changes. So if somebody comes along and says we have a massive new DB2 or a massive new CICS application, we have a way of now modeling that and applying that to our historical usage and seeing what the potential impact is going to be. Now we're going to go back to our base level data, and we're going to show how we can use some other advanced features in VPAT to help us in our capacity planning decision-making process. So let's click start, and we're going to leave this value defaulted just as we have before. Only now we're going to go in here and we're actually going to specify that we anticipate we're going to need a 10% growth across the board in our next year of processing. And we need to forecast what the impact of this is going to be. So we say, okay, here, and we've now essentially applied 10% growth to every LPAR. Now, this is very similar to doing this with the annualized growth, but this is going to allow us a little better drill down, a little better understanding of what the impacts are going to be, as we'll see. So as we click OK here, we can now see that we have our same MIPS utilization, MIPS numbers here, and we can actually see here that we anticipate that 10% growth across the board in all of our LPARs is actually going to push us above the 7-Eleven's capacity. That may or may not be a problem. We may or may not want to be concerned about that. So again, if we look here, if we were to stay on our 710 with this growth, well, this is going to be very similar to what we just saw, where we've got a much longer period of time at 100%. We understand that. And we've also driven our other peaks here to 100%. So what if we look at this on the 7-Eleven? Now we look at this model and we look at this growth and we look at this chart and we say, well, we do have more demand here and we do have a longer period at 100%. I wonder what the impact is going to be. So what if management comes and says, I want you to make this fit on the 7-Eleven. We don't want to spend another engine. Well, VPAT allows us, when we have this sort of view here, VPAT allows us to click in the legend, and it allows us to see what's called a deficit view of capacity. And it's going to let us know whether the LPARs, with their increased workloads factored in the 10% growth, will fit and perform as they did before within their allocated weights. So let's click on the Dev 7 LPAR, and we can see he's very low CPU allocation, and that's his weight in MIPS he can get. And it looks like he fits fine in there. I don't see anything really issue. He's a very low used LPAR. So let's return back, and we can click on Dev 6, and we can see the same sort of information. And we can click on Dev 5. Now, Dev 5 is a fairly bigger LPAR. We can see up here, Dev 5 is this blue LPAR. So let's see what's happening here. And again, he fits. But it's interesting, he's actually using above his allocated weight at times, which is nice because he's supposed to use free capacity on the machine. We expect that. Now let's click up here to production and see what the impact in production is going to be. Well, Dev 4, we can see he's probably going to be fine. He's living within his allocated weight pretty much all day long. And if we look at Dev 3, we can make the same conclusion that probably won't, this will probably run unfettered. But let's look at Prod 3, and now we see, we may have a problem. So when VPAT is projecting out the increased workload that we forecasted in with the 10% growth, VPAT is saying, well, everybody's going to increase by 10%. And the 10% increase overall is going to keep the machine at 100% here. And the production LPAR weighting here is actually quite low. And it means that the combined usage of the other LPARs who are guaranteed capacity here is going to drive Prod 3 to have a net deficit in CPU capacity. Now, VPAT is cumulatively adding this up. It's saying if you're short 100 MIPS here and you're still short 100 MIPS at the next interval, well, it's really a 200 MIP deficit. And if it's another 100 MIPS, we're up to 300 now, and it could go higher. What this really means is that you're going to need a period of below 100% capacity where Prod 3's usage is going to rise higher to make up for this lost deficit. If we don't do anything, this red area is going to indicate a potential performance problem, and we'll have to understand that. But what else can we do here to help this out? Let's go back to our weighting panel. And this is where VPAC can actually help us make decisions. So what if we adjust the weight and we steal some capacity from the Dev5 LPAR? Let's reduce him from a weight of 88 to a weight of 10. And then let's go up here and let's change this from a weight of 802 and let's add that 78 back in and let's make it 880. We now add to the same 100%. And now when we click on utilization against the 711 LPAR, well, we still see the same thing. We still see the same utilization pattern. But when we click on prod 3, we can see now that our weight is closer to our allocated capacity now. And we can see that we've resolved the potential performance issue in prod 3. What has happened? Well, if we click on dev 5, we took away from him. So we know he's going to now reflect the deficit at this point, and he's going to have a tiny deficit here. But this is a much more palatable decision to make to present to management saying we can fit, but we're going to have to impact development performance at 7 o'clock at night. That may be an acceptable decision, but now we have facts that we can make a decision around. So this is just a demonstration of some of the power in VPAT, some of the abilities to manipulate LPAR capacities, workload level capacities, and system configuration to help us make a better capacity planning decisions. Hope you found this interesting. Thanks for tuning in.